Some further applications of linear functions would be to take a look at whether their values would be greater than a given number, less than a given number, or where two linear equations would intersect. So let's suppose that I have f of x equals 4x minus 1 and g of x equals negative 2x plus 5. Let's go ahead and solve when f of x would be greater than 0. So I'm going to have f of x, which is 4x minus 1, is greater than 0. So I'm going to add 1 to both sides. 4x is greater than 1. Divide both sides by 4. I get x is greater than 1/4. So my function, my y value of this function, f of x, as long as x is greater than 1/4, has a y value greater than 0, if we were looking at a graph. Next, let's solve f of x is less than or equal to g of x. So I want to see when do my y values of my function f of x, when are those less than or equal to my y values of g of x, right? G of x stands for the y values of this specific function. So I've got 4x minus 1 is less than or equal to negative x plus 5. So let's combine like terms. I'm going to add 2x to both sides, add 1 to both sides. I want to get my constants all on one side, and I like my x's lonely. So let's go ahead and divide both sides by 6. X is less than or equal to 1. So as long as x is less than or equal to 1, my f of x, my function's y values for f of x are less than or equal to that of g of x. I skipped 2 problems. Okay, what if I want to know when my function equals 0, when f of x equals 0? I'm going to go ahead and set my function equal to 0, add 1 to both sides. I get 4x equals 1, so x equals 1/4. So this is saying when y is 0, x is 1/4. We found right here our x-intercept. That's kind of cool. Next, I want to know when f of x equals g of x. So I'm asking, when are these y values equal? At what x value would these y values be equal, or where would they intersect? One way to take a good look at what's going on is if you want to go ahead and graph this in Desmos or your graphing calculator, so you can visualize what's going on a little bit better. So I have 4x minus 1 equals negative 2x plus 5. I'm going to add 2x to both sides. I'm going to add 1 to both sides. So I get 6x equals 6, so x equals 1. Okay, so this is the x value where my y values are equal. But what if I wanted to figure out that exact point where those two lines intersect? I could substitute in x equals negative 1. And I could substitute it into either of my functions f of x or g of x, and I get the same answer. So let's look at g of 1 equals negative 2 times 1 plus 5. So g of 1 equals 3. Okay, that means that my function is going to intersect when x is 1. My two lines are going to intersect when x equals 1 and y is 3. This is our point of intersection. And that's all I have for you in section 2.1.